We have a player's ship, weapons, and hazard objects. We need to bring them together into a simple but playable game. To do this, we need to create a game controller to run our game, to spawn our hazards, keep track of and display our score, and when our player is destroyed, end our game. First, create a new game object to hold our game controller logic. Rename this game object Game Controller. And then reset the transform. For this game object, this step isn't absolutely necessary, as this game object will not have a physical presence in our game. It won't have a collider, and it won't be rendered. That being said, it is always best to keep everything in our project neat and tidy, and there is no good reason not to put the game controller cleanly at origin. Using the tag drop-down menu in the header of the game controller game object, select the pre-made tag Game Controller. With our game object set up, let's write our logic. With the game controller selected, use the Add Component button to create a new script named Game Controller. Accept the changes to add this new script to Game Controller. Select Assets and file the Game Controller script in the Scripts folder. Open the Scripts folder and open the Game Controller script for editing. Our Game Controller will perform several different tasks. The primary task, however, will be spawning the hazards in our game. So the first thing we will need in this script is a public game object reference to our hazard. Next, we need to do something with these hazards. We need to spawn them, preferably in waves for our player to fight through. Let's write a new function to spawn our waves of hazards. Write void spawn waves. Now, we need to call this function. There are some functions that are called automatically by Unity, but most of the functions that we write, we will need to call ourselves, or they won't be executed. We want our spawnWaves function to work for most of the duration of our game. So let's call spawnWaves from start. So let's write void start. Unity will call start on the very first frame that this game object is enabled, and then start will call spawnWaves. What do we want spawnWaves to do? We want spawnWaves to instantiate our hazards. We want to instantiate our hazards at a spawn position with a spawn rotation applied. We have 3 parameters for instantiate, and we need a value for each of them. Let's look at each of these parameters, one parameter at a time. Our object, hazard, has already been defined as a public variable. Our spawn position is a vector3 value, so let's create a vector3 variable called spawn position, which we will set to a new vector3. Our spawn rotation is a quaternion value, so let's create a quaternion variable called spawn rotation, which we will set to a new quaternion. Both of these will change before we're done. Let's look at how we can assign working values to these. Hazard is a public variable. We can set this directly in the inspector. Save this script and return to Unity. We can see the hazard property on the game controller component. In the prefabs folder, we can find our asteroid prefab. Drag the asteroid prefab onto the game controller component and drop it onto the hazard slot to create the reference. We want to be able to set our spawn position in the editor as well. Return to our game controller script. For our spawn position, let's define a public vector3 variable called spawn values. Why can't we just use spawn position here? We will see why in just a moment. Patience. Save this script and let's set spawn value in Unity. To help visualize this, let's drag an asteroid prefab into the scene temporarily So, on what position along the y-axis do we want to spawn our hazards? On the XZ plane or the game plane. So 0 on the y-axis. What about the position on the XZ plane? This could be better seen through the game view camera. What position on the Z-axis? Up, out of the game area. That looks like about 16. So let's set the spawn value Z to 16. Now, what about the x-axis? Well, we can't really use a single value here. If we did, we would define a single point for our spawn position. And for that, we could have used a simple GameObjects transform, like we did for the shot spawn on the player's ship. What we really want here is a random point on the x-axis, one that is a new random value for each new hazard we spawn. This is why we couldn't use spawn position directly. Let's return to our script. We will use our spawn values to set a random spawn position. Our spawn position is made up of x, y, and z values. Working from back to front, our spawn position z will be our spawn value z, or outside the top of the game area. Our spawn position y will be our spawn value y, or 0, on the game plane. Our spawn position x is the one that's more tricky. We can't use a single value here. We will use our spawn value x to control a random value. Let's search the documentation for random again, so we can look at the random class. In this case, we want to look at random range. We give random range a min and a max value, and random range will return a random value between those two values. This means we can feed random range with the values of the edges of our game area, and it will return a random value between them. Copy random range and return to our script. Paste random range into our code, and let's feed random range with minus spawn values x and spawn values x. Save this script and return to Unity. Where are the edges of our game? Let's move our asteroid along the x-axis, and it looks like about -6 and 6. So spawn values x is 6. Lastly, we need to set our spawn rotation. Back to our game controller script, let's find out more about quaternion in the documentation. Quaternions are complex. We almost never access or modify a quaternion directly. There are many quaternion functions for us to use. We won't be using any of the quaternion functions exactly, but we will be looking at a quaternion property called identity. Quaternion identity corresponds with no rotation of the quaternion. We will instantiate our hazards with no rotation at all. Copy quaternion identity and return to our script. Paste this into our code so the line reads quaternion spawn rotation equals quaternion identity. Save this script and return to Unity to test. Remove our temporary asteroid, save the scene and play. And we get a tumbling asteroid from a random point left to right, starting outside of the game area and moving along the game plane. Let's enter and exit play mode a few times. We can see that our spawn points are random, and each new asteroid is spawned at a new random location. In the next assignment, we will instantiate waves of hazards to challenge our player with.